Hi, this is Anthony Vanderwood. In this short video, I'm going to talk to you about what incremental forever with virtual full actually means and what the implications for using this technology are on the way Actifio actually delivers value to our customers. Now, if you think about the typical challenges most organizations are struggling with, they're well understood. And the challenge for most vendors in today's marketplace is they can't actually solve all five of them. They might solve two, they might solve three, they can't solve all five. Actifio realized that if we could build a platform that brought together these five fundamental capabilities of incremental forever with instant recovery, the ability to rewind and recover very quickly while dealing with the whole challenge of test and dev, we could bring to the marketplace a unique product which solves a problem that is frankly challenging almost every organization that we ever have met. So how do we actually do it? I'm going to use a theoretical database here. The size is unimportant. The goal here is to show you how we would do an incremental forever data protection regime. Now, the interesting thing is that this methodology that I'm going to explain is exactly the same for virtual machines, databases, file systems, CIFS shares. It does not matter. The same mechanism applies to every single data type we protect. So we discover a large database, and at midnight we begin protecting it. So the first thing we do is we construct a virtual disk in our snapshot pool. Now, if the database is very large, tens of terabytes, we'll actually create multiple virtual disks and stitch them together with the same native format that the source has, whether it's ASM or whether it's an LVM. The target will look and feel exactly the same way. I'm just showing you one disk for simplicity. At midnight, we use a methodology to quiesce the database to get a consistent view of the database, and we begin copying the database into our virtual disk so that at the conclusion of the job, we have a full copy of the database as it looked at midnight. One more step, we snapshot that database, that copy, using our own internal snapshot technology to give us a consistent point-in-time view of the database as it looked. We can then use this midnight snapshot to create virtual copies, effectively snaps of a snap, and present them on demand to your users. That's midnight. Let's say we have a policy that says take a snapshot of the database every 4 hours. So 4 a.m. comes along. We transition this full copy on our staging disk from midnight to 4 a.m. So we literally copy the change blocks that have occurred on the source from midnight to 4 a.m. We copy them in. Now I've shown them down the bottom here. Obviously they'll be spread across the disk. That's unimportant. But what I'm showing you is that there will be a volume of changes we discover through a change block tracking mechanism. We copy them directly into the staging disk. Now, what this does is that it obviously causes changes to the staging disk that we were protecting with that snapshot we created. So the original blocks get moved to the snapshot and the new blocks get written into the staging disk. The conclusion of which is that at after the job's finished, sometime after 4 a.m., the staging disk now looks like the source did at 4 a.m. And the snapshot shows what the source looked like at midnight. And again, to conclude this operation, we create a snapshot of the staging disk to give us a point-in-time view of 4 a.m. and midnight. And again, as I said, I can then take a snap of either of these, present them out as a virtual mount, and you can then get a view of the database at midnight or at 4 a.m. What happens at 8 a.m.? Exactly the same thing. We bring in the changes that occurred between 4 and 8 a.m. We write them into the staging disk. This is not so much an incremental merge as literally an overwrite of the original data, transitioning the staging disk from 4 a.m. to 8 a.m., at the conclusion of which the change blocks will be protected by the 4 a.m. snapshot, the new blocks will be written directly to the staging disk, and we conclude this with a snapshot at 8 a.m. And again, as I said, we can use any of these points in time to present virtual copies of the database as it was at 8 a.m. Midday comes along, exactly the same process. And this process continues by policy for as long as we want it to continue. Now in this example, let's say I'm taking a snapshot every 4 hours. I am retaining the snaps for 2 days. So you can see I have midnight now, midnight 1 day ago, midnight 2 days ago. Now, I can additionally design a policy, and I'm going to go a little bit backward here. I can design a policy that not only keeps a copy in the Actifio snapshot pool, but also deduplicates and compresses that point-in-time view and pushes it into the Actifio dedupe pool. So this little orange disk here represents a view of this snapshot as it was at midnight. but using only deduplicated and compressed blocks and some metadata to describe exactly the layout of the disk as it was at midnight. So this exists in the dedupe pool. So we could dedupe this disk at midnight every day, capturing an image in the dedupe pool that looks like the snapshot did at that point in time. So again, after 2 days, I've got midnight from 2 days ago, midnight from 1 day ago, and midnight now. All of those points in time preserved in the dedupe pool, and that can be used for medium-term retention. In addition, on top of that, I could optionally move a snapshot, copy an entire snapshot into object storage, into a bucket in S3 or in CleverSafe or whatever supported object storage target that you can provide to us. We can place a copy of snapshots into object storage. In addition to that, we can also do log protection. Now, what this means is that on a fixed interval, say 15 minutes, 30 minutes, in between these snapshots, for Oracle and SQL databases, we can be capturing logs and storing them for a preset period of time. That could be, say, 30 days worth of logs. So while I'm maintaining 2 days worth of snapshots at 4-hourly intervals in the snapshot pool, and I'm maintaining an image from midnight in the dedupe pool, say for 3 years, I can also be capturing logs for 30 days rolling forward, and I could be doing this on 15-minute increments. And interestingly, see how the arrow goes past midnight? Because imagine it's 3 a.m. If I'm capturing the logs every 15 minutes, I could take this midnight point in time, and if I've got the logs all the way forward to 3 a.m., I could roll that forward to 3 a.m. with those logs. Now, one of the things is that snapshots don't last forever. At some point, we need to expire them to release space in the snapshot pool. So what happens when I expire the midnight snapshot from 2 days ago? It's no longer present. So how do I recover to that midnight point in time? I have an image in the dedupe pool. I can combine 3 things together to rapidly recover, say, this point in time or a midnight from days prior to that. What we do is we select this point in time out of the dedupe pool. The Actifio snapshot engine identifies the snapshot that's got the closest consistency point, which in this case is 4 a.m. Remember, it's only a 4-hour difference here. We create a snapshot of this snap. We merge any blocks out of dedupe into that new virtual snapshot, and then we could even use logs to roll that forward to a future point beyond that. So we were able to access points in time past the expiration date by using the combination of deduplication and log protection. Now, I wanted to very quickly explain how the change block tracking mechanism works, because you saw in those earlier slides that small bit of orange data that appeared in my staging disk, the changes that occurred between midnight and 4 a.m. or 4 a.m. and 8 a.m. How did Actifio identify those changes and move just the change blocks? Now, what's interesting is I'm going to show you 5 pictures or 4 pictures that look almost exactly the same. VMware virtual machines, we use VMware's change block tracking. So when we begin to protect a virtual machine, we turn on change block tracking. We use VMware snapshots to preserve a version of the virtual machine at a particular point in time. We copy just the change blocks across either fiber channel or LAN onto the Actifio staging disk, basically writing it directly over the top of the previous blocks, but protecting the previous blocks with those internal snapshots, which can then be presented instantly for on-demand recovery or instant test and dev. Now that's VMware. If I look at an Oracle database, notice how the picture looks almost exactly the same. There's literally only one tiny difference. Well, it's not tiny, but from a theoretical perspective, it's just one small difference here, which is that the change block tracking is going to be provided by Oracle, not by VMware. The ability to get a consistent point in time in the database is provided by RMAN. But the mechanism and the way we implement it is identical. We identify the change blocks, we write them to the staging disk, we preserve the previous point in time with internal snapshots, and we are able to present those internal snapshots on demand providing instant recovery and instant test and dev. Microsoft SQL and Exchange, the only difference is the change block tracking is provided by an Actifio supplied driver, which we install onto the Windows server non-disruptively. Track the changes, copy the changes. Exactly the same mechanism. Linux databases, so whether this is a Postgres or MySQL, we use an Actifio supplied change block tracking driver, which we insert, tracks the changes, we copy the changes, we do exactly the same mechanism. So what you've seen is that from a solution delivery perspective, we have a solution that captures data, stores it in the native format, gives you log protection with databases, utilizes deduplication for medium-term retention, uses object storage for long-term retention, and genuinely delivers incremental forever with virtual fulls to give you that instant recovery, automated refresh, rewinds, whatever it is you need to do with that data. Hopefully this has been useful to you. Thank you very much for listening.